In the summer of 1950, the world was holding its breath. The embers of one global conflict had barely cooled while the specter of another, a cold and atomic war, cast a long shadow. At the Los Alamos National Laboratory in New Mexico, the very place where the atomic bomb was born, some of the world's most brilliant minds were gathered. They had harnessed the power of the star, and now, during a casual lunch, their conversation drifted towards the stars themselves. The topic was a recent spate of UFO sightings, a popular subject in post-war America. The scientists, including Edward Teller and Herbert York, were discussing the feasibility of faster-than-light travel. Among them was the Italian physicist Enrico Fermi, a Nobel laureate and a man renowned for his ability to perform complex calculations in his head with startling accuracy. He listened quietly to the optimistic chatter about alien visitations. Then, amidst the clatter of cutlery and talk of interstellar voyages, Fermi fell silent for a moment. He looked up at his colleagues and asked a simple, yet profoundly unsettling question. "But where is everybody?" The room went quiet. The other scientists understood immediately. Fermi wasn't just asking about the UFOs from the morning cartoons. He was asking something much bigger. Given the age and sheer scale of the universe, the billions of stars in our own galaxy, and the billions of galaxies beyond, there should be countless planets capable of supporting life. A fraction of those should have developed intelligent life, and a fraction of those should have developed interstellar travel. Even at sublight speeds, a civilization could colonize the entire Milky Way galaxy in a few million years, a mere blink in cosmic time. So, the logic dictates, the sky should be teeming with evidence of alien civilizations. We should see their probes, hear their signals, or witness the grand engineering projects of a Kardashev Type 2 or 3 civilization. Yet, we see nothing, we hear nothing. The universe is unnervingly silent. This is the heart of the Fermi paradox, the stark contradiction between the high probability of extraterrestrial life and the complete lack of evidence for it. To formalize this intuition, astronomer Frank Drake, a decade later, would devise the now famous Drake equation. It's not a proof, but a probabilistic argument, a way to organize our ignorance. It multiplies a series of factors: the rate of star formation, the fraction of those stars with planets, the number of those planets that are habitable, the fraction on which life actually arises, the fraction of that life that becomes intelligent, the fraction of intelligent life that develops detectable technology, and finally, the length of time such a civilization broadcasts its existence. When you plug in even the most conservative numbers, the equation often spits out a result suggesting that there should be thousands, if not millions, of intelligent civilizations in our galaxy alone. Yet, the great silence persists. Where is everybody? The answers to this question range from the hopeful to the utterly terrifying. One category of solutions suggests that we are, for some reason, special. This is the rare Earth hypothesis. Perhaps the chain of events that led to us is so astronomically improbable that it has happened only once, right here. It's not just about being in the Goldilocks zone where liquid water can exist. It requires a stable star of the right size and composition. It requires a large moon like ours to stabilize our axial tilt, preventing wild climate swings. It requires plate tectonics to regulate the climate and recycle crucial elements. It requires a magnetic field to shield us from cosmic radiation. It requires a giant planet like Jupiter to act as a cosmic bouncer, sweeping up potentially devastating asteroids. The list goes on and on. If you multiply all these low probabilities together, you might find that Earth is not just a rare gem, but a singular miracle. We are not just one of many, we are the only one. In this view, the great filter, the impossibly difficult step that prevents life from becoming interstellar, is behind us. We passed it. We won the cosmic lottery. The silence is not a mystery. It's the natural state of a barren cosmos. But what if the filter isn't the planet, but life itself? Perhaps the leap from non-living chemistry to the first self-replicating organism is the great filter. We still don't fully understand how abiogenesis occurred on Earth. It might be a 1 in a trillion fluke, or maybe simple life is common, but the jump to complex, multicellular life is the barrier. It took over 2 billion years for life on Earth to evolve from single-celled organisms to something more complex. Or perhaps the final, most difficult filter is the emergence of human-level intelligence and technology. After all, of the billions of species that have ever existed on Earth, only one has built radio telescopes and spaceships. In any of these scenarios, we are the first. The silence is the sound of an empty stage waiting for the play to begin. We are the opening act. A second, more unsettling category of solutions posits that they are out there, but we can't see them. They might be hiding, or we might be looking in the wrong way. The zoo hypothesis suggests that we are being deliberately left alone. Advanced civilizations may have established a galactic policy of non-interference with primitive cultures like ours. We are cosmic nature preserved, observed from a distance, but never contacted to allow for our natural development. This is the prime directive of Star Trek made real. They are watching us, perhaps with scientific curiosity, perhaps with amusement, but they will not reveal themselves until we reach a certain technological or ethical maturity. A far more chilling version of this idea is the dark forest hypothesis, popularized by author Hugh Sixon. This theory frames the universe not as a welcoming community, but as a dark forest filled with silent hunters. In this forest, every civilization is a potential threat. Since you can never know the intentions of another civilization, whether they will be peaceful or hostile, the safest course of action is to remain silent. Any civilization that reveals its location is like a child shouting in the dark, immediately drawing the attention of predators. The first law of cosmic sociology is to hide. The second is that if you do find someone else, you must destroy them before they destroy you. In this terrifying scenario, the great silence is not an absence of life, but a testament to its intelligence. The silence is a carefully maintained state of fear. The civilizations that survive are the ones that have learned to hold their breath. Our radio broadcasts, from the 1936 Olympics to the constant stream of television and radar, have been leaking into space for decades. We have been shouting in the dark forest, and we can only hope that no one has heard us yet, or perhaps the issue is more mundane. Maybe we are simply using the wrong tools. We scan the skies for radio waves, a technology that is only a century old for us. What if an advanced civilization has moved on to far more sophisticated means of communication, like modulated neutrinos, gravitational waves, or some form of quantum entanglement that we cannot yet even comprehend? It would be like trying to join a global fiber optic conversation using smoke signals. They may be chattering away, filling the cosmos with information, but we lack the senses to perceive it. The universe isn't silent. We are simply deaf. The third and perhaps most sobering category of solutions suggests that the great filter is not behind us, but ahead of us. This implies that intelligent life is common, but something inevitably prevents it from reaching a galactic scale. Civilizations rise, develop technology, and then, without fail, they destroy themselves. This is a chillingly plausible scenario. Once a species discovers nuclear power, it gains the ability to wipe itself out in an afternoon. As technology advances, new existential threats emerge: runaway climate change, genetically engineered plagues, uncontrollable artificial intelligence, nanotechnology, grey goo. Perhaps every technological civilization faces this gauntlet of self-inflicted dangers, and none, or very few, ever make it through. The silence, in this case, is a graveyard. It is the sound of failed civilizations. When Enrico Fermi first asked his question, he was surrounded by the architects of the atomic bomb. He understood better than anyone that the same intelligence that allows a species to reach for the stars also gives it the power to extinguish its own sun. Beyond self-destructs, there are natural cosmic dangers. A nearby supernova or a gamma ray burst could sterilize an entire quadrant of the galaxy in an instant. These events are random but inevitable on cosmic timescales. Perhaps life is constantly being reset, flourishing for a time before being scoured clean by cosmic radiation, never getting the chance to establish a lasting interstellar presence. Finally, there is the simplest, and perhaps most humbling, explanation of all: the problem of scale. The universe is not just large, it is incomprehensibly vast in both space and time. The distance to the nearest star system, Proxima Centauri, is over 4 light years. Our fastest probes would take tens of thousands of years to get there. Interstellar travel might be so difficult, so resource-intensive, and so time-consuming that virtually no civilization ever bothers with it. Why spend millennia traveling to another star when you can explore infinite virtual worlds at home? Even more profound is the scale of time. The Milky Way is over 13 billion years old. Human civilization has existed for a mere 10,000 years, and our technological era is only a few centuries old. It's entirely possible that thousands of civilizations have risen, flourished for 100,000 years, and then vanished long before life on Earth even crawled out of the oceans. It's also possible that thousands more will rise long after our sun has died. The chance of 2 civilizations existing not only at the same time, but also close enough in space to communicate, might be vanishingly small. We could be ships passing in the cosmic night, separated by an impassable ocean of time. For now, we continue to listen. Projects like SETI, the search for extraterrestrial intelligence, have been scanning the skies for decades. From the pioneering Project Ozma in 1960 to the sophisticated Allen telescope array today, we've sent our own messages, like the Arecibo message of 1974, a digital postcard beamed towards the M13 star cluster, a greeting that will take 25,000 years to arrive. The discovery of thousands of exoplanets by missions like Kepler and TESS has only deepened the paradox. We now know for a fact that planets are not rare, they are everywhere. Nearly every star you see in the night sky likely has at least one. So we are left where Enrico Fermi left his colleagues in 1950, with a profound and unanswered question. The great silence of the universe is like a cosmic Rorschach test. In it, we can see our own loneliness, our own potential, or our own doom. Are we the first, destined to be the progenitors of a galactic civilization? Are we a protected species in a cosmic zoo, a curiosity for unseen zookeepers? Are we fools, shouting in a dark forest, about to attract the attention of something ancient and hungry? Or are we simply alone, a brief, accidental flicker of consciousness in an immense and indifferent void? The answer, whatever it may be, will fundamentally change our understanding of our place in the universe. Until that day comes, we will continue to look up at the stars, listen to the profound silence, and wonder, where is everybody?